All right, guys, we were just about done with this really long section of notes right here in 7.1. Last time we were together, we had just finished up this problem here where we were using this formula for compound interest, which is a little bit complicated, but hopefully we're getting the hang of that pretty quickly here. So we had done this problem here where we talked about just how much it can cost you to buy a $1,300 TV on a credit card with a high interest rate for something compounded monthly. So we talked about how interest can work against you when you're borrowing money, but it can also work for you when you're actually saving some money. And this problem here is an example of that. So in this one right here, you're going to make a $3,500 deposit into an account that's going to earn 4% annually. And that annually word means per year. That's pretty important. But they tell you here that your interest is compounded quarterly. So the first thing we probably ought to figure out is that when that word shows up from time to time, remember that in all of these problems, n was the variable we were using to figure out the number of times per year that your interest was going to be compounded. Quarterly means once every quarter, 4 times per year. So just by reading the word quarterly, we can tell that n is going to equal 4. And the question now is, if you leave that money alone now, what's it going to be worth after 5 years? So we're going to use the same formula we talked about here last time we were together. This variation on that exponential growth formula here that's kind of tailored just for compound interest here. So we're going to have A is equal to P, and then in parentheses 1 plus an r over n, all raised to the nt power. And again, the question now is asking us how much will the account be worth after a set amount of time. That means we're looking for A. We're looking for the final value of what this account is going to be at the end of this period. The P stands for principal, which means the amount of money that you initially saved. So for us, that's going to be $3,500 in this problem. And then in parentheses now, it's going to be a 1 plus. The R is your annual percentage rate, which we want to express as a decimal. And 4% as a decimal is going to be 0 point and a 0.4. A lot of people make the mistake of making that 0.4, which would actually be 40%. So there's R. We're going to divide that by N, which we said, number of times per year compounded, is going to be 4. Let's close that parenthesis off. And then the exponent is n times t, where n is 4, and then our account, or our amount of money, is going to sit there for 5 years. So t is always going to be measured in years, which is going to be 5. So we've seen quite a few problems like this in this section here already. Everything on the right-hand side is a constant. There's no variables here. So we're just going to type all of that into the calculator at once. So I've got my calculator here. I can't show you guys this, but hopefully you can do this with me and you'll get that same result right here. I'm typing in just like it looks, 3,500, and then in parentheses, 1 plus 0.04 divided by 4. We're going to close our parenthesis there and then take that to a power of 4 times 5. And if you wanted to just put 20 in for the exponent, that would probably make your life a little bit easier. But doing all that, I ended up with a final account balance here. Hopefully you got the same thing, of $4,270. And with money problems, we're always going to round to the nearest hundredth because that's cents. 67 cents there is what we have. So not too bad. Our $3,500 investment, if we just left it alone for 5 years, got up to $4,200. So not too bad of a growth on that one. And then just a little variation on that same problem there for the account that we just did. How long would it take for your amount to double? So we saw some problems like this with the Range Rover last week. This is using the same formula we talked about. A is equal to P, and then in parentheses 1 plus R over N, but raised to the NT power. And now this time, the question here is, how long will it take? It's a question of time, which means that's going to be the one variable that we don't have a value for. We need to put in everything else. So A is the final amount we want this to be worth. Well, we said here that we were investing $3,500 into this account. For that to double, our final amount would have to be $7,000 because that's twice as big as the $3,500 principal that we started with. And then in parentheses, 1 plus, we're not changing the rate here at all, so that's still going to be 4% or 0.04. We're still compounding our interest quarterly, so N is still still 4, but then up here the n we have is 4 and the t is the unknown variable there, so that's going to be a 4t power. And as I told you guys earlier, this is a complicated equation to solve that we're going to learn how to do later on in the chapter. But for now, the way we're going to handle it is that we're going to cheat and use the calculator here, and we're going to graph the left side of the equation, and that I usually do in red, which is y2. And at the same time, we're going to graph the entire right side of the equation and get that one and call that y1. So again, I can't really show you guys this because I don't have a TI-84 app on my iPad here, but I'm going to go ahead and I hit my y equals button, and first I'm going to start off with what we have over here on the right-hand side. So I'm going to type in 3500 and then in parentheses 1 plus 0.04 divided by 4, close the parenthesis, and raise to a power of 4, and instead of a t, we're just going to hit x, and we will hit enter. And then for the second equation, y2 in red, I'm just going to type in this $7,000 amount right over here. So y2 in my calculator just says 7,000. And I hit enter. And now when I hit graph, nothing really happens. So I've got to go and hit my window button, which is F2 up at the top. And I'll make some notes of this here, guys. So in fact, let's write that down. This is F2 on your calculator, window. So we've got to make a few changes right here. The first thing it's going to ask us for is an X minimum. And remember that X is in the place of this T right here. The lowest value of time we would want to deal with would be 0. And now for, so we'll do a 0 there. And then for X maximum, not really sure how long this is going to take to double. If I go back to the last problem, in 5 years, boy, it did not double. It went up by 700. So I'm going to take a guess here, and I'm going to put a big number. You're always better off guessing large here. I'm going to put 20 for my X maximum, and I'm hoping within 20 years this amount is going to double. Let's take a look at what's next then. You never have to worry about X scale, so I'm going to leave that at where it was, which was just 1. And then it's going to ask for a Y minimum. Now Y, if you recall, is taking the place of A right here. The lowest amount that your account is ever going to be worth, really 3,500 is the lowest it's ever going to be. That's what you started with, and it's not going to go down from there. So you could put 0 in. That would make some sense too, but I'm going to put in 3,500 for my Y min, and then my Y maximum, I just need to make sure that I put in a number bigger than that 7,000. So I'm going to put 8,000 just to give me a little bit of room there. And when I hit enter there and graph, I'll kind of sketch for you guys what it is that I'm seeing here. So I've got a graph that looks something like this and this. And let's see, my blue curve from Y1, okay, I think we're in pretty good shape, is like a slow, gently increasing curve that looks like this. And then my Y2, that constant amount of 7,000, is a horizontal line that comes across like this. And I was just guessing, but I think I guessed right, that 20 years was enough, because it looks like we have a point of intersection right here that I'm seeing on this graph if we used those parameters for our window. So now we want to go ahead and we want to use the calculator to find that point of intersection. So if you remember how to do this, guys, we are going to hit second, and then from there we're going to hit F4. That gets us to the calculate menu, so second F4, and then from there we're going to hit number 5, which is the intersect key. So we'll do that. And now it's asking me first curve, and the cursor that it gave me is blinking here somewhere. So I'm just going to hit my right arrow a bunch of times, and what that's going to do is it's going to move that blinking cursor, which is actually black, sorry, closer and closer to the actual point of intersection. So when I get it right about there, then I hit enter on my calculator. And let's make life easy again, guys. We're just going to hit enter 3 times. So enter on the second curve, and then it asks for a guess, and I'll hit enter again. And it now tells us that that intersection right here, let's jot this down, is 17.42. So 17.42, comma, and not surprisingly, the Y value there is 7,000. And so, trying to answer the question now, how long will it take you for your principal to double? That X value there is how much time it would take. So I'm going to write my answer right here nice and big, and I'll box it up. T is equal to 17.42 years. So with all those conditions and parameters that they talked about, that's how long it would take that thing to double, to get up to 7,000. All right, guys, that is finally the end of a really long section of notes here on 7.1. So hopefully with all that written down, you guys can get a good start on the 7.1 homework, and we'll talk about 7.2 in the future here. Good luck.